The time has come to begin creating our game controllers. And I'm a big fan of creating game controllers that are going to well control our game. So we are going to have a menu controller, gameplay controller, ads controller, social media controller, so on and so forth. Our game controller here, for example, is going to store and well control all the game relevant variables. So for example, it will keep track if the green or the red bird are unlocked. It will also keep track and save the high score, so on and so forth. You will also create an empty game object, so go under game object, create empty and name it game controller. In our prefabs folder, create a game controllers folder and save it there as a prefab. Also here in our scripts folder, create a game controllers folder, create a game controller C# script, attach it to our game controller, hit apply so that those changes apply to our prefabs. And from now on, for each game controller that we create an empty game object, name it by its appropriate game controller name, save it as a prefab, also create that same script, well, for that appropriate game controller and attach it to that game controller. And also now we can click on our game controller script so we can open it in MonoDevelop and start well coding. First, we will create a couple of variables, and the first one will be our public static game controller instance, so a reference to our class. Next, we'll create a private constant string, and this will be our high score. So it will be high score and is equal to, so let me just type that right, so it's equal to high score like this. So what does this constant here mean? Well, basically a constant is a variable that will never change. And I see that we need to add one more quotation mark here. So basically that will fix that problem. And as I said, constant means a variable that will not change. The same way as in mathematics. So in programming, when we have a variable that's not going to change, in our case this high score, we can simply mark it to be a constant and we cannot change it. The next variable that we need is selected bird. So here I will just type selected and well bird here. And also here, well, for the value it will be selected bird like this. And we need two more variables which are also going to be private constant strings, and this will be our green bird. So let me just type that right, so green bird, and well, the value will be green bird like this. And the last one is our red bird. So here I will just, instead of green, type red, and also here instead of green I will type the value to be red bird. Now we will create a singleton out of our class, and here instead of our update function I will simply say void make singleton, so make singleton like this, and this is a function. And here we are going to check if our instance is not equal to null, meaning we already have an instance, then we are going to destroy the game object that's holding this script. Else, if we don't have an instance, we are going to well make this script that instance, so it will be instance is equal to this, and after that we are going to say don't destroy this game object, so simply type it like this. Now what this means, basically we are checking if our instance is not equal to null, meaning we already have an instance of this class. If that is true, then we will destroy the game object that is holding this script. Else, if we don't have an instance, then we will make this class that instance, and we will not destroy unload the game object that is holding this class. Now, in order to well understand this better, I will show you one example, and then you will well understand why we are doing it like this. So I have created two scenes. One is named test scene 1 and the other is test scene 2. I have also created a test script and attached it to a game object, and each of these scenes only have one UI button in them. And I have also attached that game object to that button because if we go in our test script, we have two functions. One is go to test scene 1 and the other is go to test scene 2. So only attach those two in order to, well, basically test this out. But you don't have to, because I only want to demonstrate why we need to use a singleton pattern. Now, in order to navigate from one scene to another, we need to add those scenes to the build. And we do that by going under File and then Build Settings, and after that click on this Add Current, and it will add the current scene that you are currently in. So now we are in test scene 1. If we click Add Current, it will add that scene to the build here. And also we navigate by using Application, Load Level, and we pass the name of that scene as a string. Now, if we go back in the Unity editor, I've added the game controller in our scene. And we want our game controller to follow us in each scene that we go. So if I, run the game now. Notice now if I click here to go to scene 2, we will not have our game controller in that scene. So I'm clicking here and we are in our scene 2 and we don't have our game controller here. If we go back, we will have our game controller here. But as I said, we want our game controller to follow us in each scene that we go. Now that's why we need the singleton pattern. And if I go back in MonoDevelop, I will call this make singleton function in our awake function. And now when I run the game, notice now when I go to scene 2, we will also have our game controller going with us in that scene 2. And if I go back to scene 2, again we will only have one game controller. And that's because we set this here. So we set if instance is not equal to null, then destroy that game object. If we try something like this, so if I only do this and I copy this code here, and here I will just comment this out. So we will just make instance equal to this and we will not destroy that game object. If I go back here, run the game now, and I go to our test scene 2, we will have our game controller. But notice now when I go back to scene 1, we will have two game controllers. So I'm going back here, we see that we have two game controllers. And that's because we did not make it a singleton. And we do it, like this basically that we did here. So we are checking if our instance is not equal to null. We are destroying that game object, which is basically a copy. And after that we are setting instance to equal to this, and we are not destroying that game object so that we can carry it with us in each scene that we go. Now that we saw for what we need to use the singleton pattern, we can move along. So now we are going to create a function which is going to be called is the game started for the first time, because we need to set initial values for our variables if we are starting the game for the first time. We are going to use something called player preferences to store our data. And player preferences enables us to store data in a key value pair. So just for demonstration, we will write player prefs dot, and we are going to say, for example, set int, and we provide a key and a value. A key is a string. So let's say, for example, high score, and the value will be, let's say, 100. So now we have saved the high score and the value is 100. If we want to get back that high score and get that value, we will simply say player prefs dot get int, and we are going to provide that key, which is high score. So we can just copy this and paste it here, and this right here will return 100 because that's the value. So this is just for demonstration purposes, and in the game we will see how that actually goes. Now, in order to know if our game is started for the first time, we can ask the player preferences if it has a specific key stored in it. So here we can say if our player prefs dot has key, and here we can provide any key as a string. So we can just copy the name of this function, and here we can say if our player prefs has this key is game started for the first time. Now this code right here will return true if we have this key or false otherwise. But because we are starting the game for the first time, this right here will be false. Now, because this statement will return false the first time we start our game, instead of writing an else statement here, because we would need an else statement to, basically initialize our game, what we can do is we can write an exclamation mark here in front of this, line of code. And what this exclamation mark does is it will convert what is after it to the opposite. So for example, if this code here returns true, this will make it false. So this exclamation mark will make it the opposite, which will be false. If this code right here returns false, then this exclamation mark will return true, or it will make that false to true. So this, code here that we type now, so here, it will be executed. And basically after that, when we set initial values, the next time we run our game, this here will return true, and the exclamation mark will make it false. Then we will not execute these lines of code. So now we can set up our initial values. So here we can say playerprefs.setInt, and we can use our high score variable, which is this variable here that we have declared. And because of this right here, we have declared all of these variables. So here we can set the high score to be equal to 0 because initially our high score is 0. Next we will say playerprefs.setInt selected bird is equal to 0, and we will see a little bit later why we are setting the selected bird to 0. Now we will set the initial state for our green and red bird, and they will be locked initially. So here we are going to say playerprefs setInt our green bird to be equal to 0. Now why we are doing it like this? Well, our player preferences, strangely enough, does not have a boolean, so we cannot say set bool green bird true or false. And because of that, we need to improvise, and we need to do the same thing for our red bird. So here I will say red bird, and when we set them to be equal to 0, that will mean that they are locked. And when we set them to be equal to 1, that will mean that they are unlocked. Again, we are doing this because we don't have a boolean in our player preferences, and we need to improvise using an integer. Now, the last thing that we need to do is save this is the game started for the first time variable. So here we will say playerprefs setInt, and here I will pass in quotation marks, and I will set it to be equal to 0 because the value is not important. The important thing is that we are storing this key, so that next time when we ask our player preferences, do we have that key, it will return true, and the exclamation mark will make it false. So we will not reinitialize our variables again, because our player can play the game and get a high score or unlock the green or the red bird, and we will reset those values, and nobody wants that. So we can just copy this here and call it here in the awake function, because the awake function is where we want to initialize our variables basically. Now we need to set up getters and setters, and they are public functions that we will use to manipulate high score and our locked and unlocked birds. So here we'll say public void, and here we'll say set high score. So set high score, let me just type that right, and here it will be int score like this. And inside of this function, what we will simply do is we will simply say playerprefs.setInt, and here we will pass our high score, and we will pass the score that we are passing here as a parameter. So it's simple as that. So this function will enable us to manipulate the high score each time we have a new high score, and we will use the instance of this class to access this function. Now, in order to get the high score, we can simply say public void, or public int, because we are returning, and it will be get high score, and here we will simply say return because we need to return the high score, and we will simply say playerprefs.getInt, and here we will simply pass our high score, which will return the current high score when we call this function. Now we need to do this for our selected bird and also for our green and red bird to know if they are locked or unlocked, and also to unlock them if they are locked. And I will quickly type that out, and I will explain what I did, because there is no need for you to watch me type it, because it's very simple and it will spare a little bit of time. So I typed all of the getters and setters. So here we have our set selected bird, where we are passing an argument selected bird, and simply inside of the function we are using setInt selected bird and passing that value that argument that we passed here in this function. We are getting here the selected bird by using playerprefs return getInt selected bird. Here we are unlocking the green bird, simply setting the value to be equal to 1, which will mean that our bird is unlocked. And here we are asking if our green bird is unlocked. We are simply returning that getInt green bird. If it's 0, it's locked, and if it's 1, then it means that our bird is unlocked. We are doing the same thing here for our red bird, and basically we are done with our game controller.